Well, hello, my name's Dirk Smith at Ionics Gas Technologies, and the purpose of this video is to explain how to use our aerosol static suppressor and reach tool. This is excellent for any safety meetings. If you're already using the product, it will help you use it more effectively. If you're considering using this product, this will explain the benefits of using it, as well as an excellent educational opportunity for your people, field personnel, to learn to deal with static ignitions. So we're going to start with this video.
A natural gas explosion rocked an Oklahoma City neighborhood just before noon today. Workers were trying to repair a ruptured line at Northwest 131st and MacArthur when the gas ignited. Newsline 9's Heidi Browning joins us live from that neighborhood. Heidi?
Well, Kelly, there's a bit of a mess out here in the neighborhood. You can see behind me what's left of a fence, charred remnants of the posts, and quite a lot of digging that's been done to make repairs to those lines. But people coming home this evening will find a much calmer scene than what many people saw this morning. It started as a fairly routine repair job. O&G workers were trying to get the gas turned off after a 2-inch medium pressure line was accidentally cut. Suddenly, the gas exploded, sending huge flames into the air. 2 workers received minor burns. O&G officials say there's preliminary speculation that static electricity in the plastic pipe somehow caused the explosion. It took about 30 minutes to control the fire and get the gas turned off.
I apologize for the quality of that. That was done at a time prior to cable, and it was recorded over-the-air broadcast. But it's the only instance of an actual third-party damage igniting while workers are on site. And the purpose of this video is to prevent that from happening to your field personnel. This chart was shared to me by Dave Zach at Aegis. He's a senior utility loss consultant for Aegis. Aegis insures virtually every gas utility in the United States. And the reason this is significant is everybody has their opinion of what causes losses or what causes damages in the natural gas industry. This is what your insurance company pays out. There's no better indication of what the real problem is than this. And if you look at this, over 80% of all the money paid out by your insurance company to local gas distributors is paid out as the result of an explosion or fire. That is more than all the other causes combined. This is telling you that your priority is to prevent an explosion or a fire. If you want to reduce your losses at your utility, this is how you're going to do it. And that's what we're going to be addressing today as we talk about static electricity and suppressing static electricity. Now, there are 4 parts to this presentation. I don't want to give you just a bunch of rules of what to do. I want you to have a little understanding of static electricity so you can recognize what it is. So we're going to talk about what static electricity is. We're going to talk about the specific field operations where static ignition awareness is required. We'll talk about best practices, and then we'll talk how our IGT Aerosol and Reach tool helps you achieve those best practices and reduce the possibility of a static ignition in your field operations. So first things first, let's make sure we're all using the same terminology. When people say static electricity, for some reason they think it's some kind of inferior kind of electricity. I mean, there's real electricity that comes out of the outlet in your house that's powering my house, that's powering my PC and recording this video. But static electricity is kind of inferior. It's not as dangerous. Not so. Electricity is electricity. The only reason it's called static electricity is because it's electricity that, unlike other forms of electricity, it's electricity that's sitting on a material that doesn't allow it to conduct. It's sitting on a material that's an electrical insulator. And therefore, that electrical charge can't move. It's static. So For instance, I'm down in Boca Raton, Florida, and up in Juno Beach, Florida Power and Light has a generator. And what that electrical generator does is it creates a whole pile of electrons. And what it does with those electrons is it deposits those electrons on a piece of copper wire. Now, copper in and of itself inherently allows for the flow of electricity to go through it. And that's essentially how they pipe it, just like you pipe gas to a service. That's how they pipe electricity into our house. They put it on a copper wire and it flows along that copper wire into that outlet and powers this PC. Now, let's just say that that same generating station, instead of taking that electricity and electrons and depositing them on a piece of copper wire, they deposit on a piece of polyethylene. Well, the problem is, since polyethylene inherently does not conduct electricity, it's in the nature of the material, that electrical charge will just sit on there. It will be static, but it is still electricity. So don't be lulled into some false sense of satisfaction that, well, this isn't really static electricity, it isn't as serious as real electricity. Oh, yes, it is. Electricity is electricity. So then, what's the problem? Well, the problem is that Mother Nature doesn't like electrical imbalances. The whole physical natural world is intended to be at electrical neutrality. And so what happens is, when static charges build up at surfaces, they want to arc to ground to neutralize each other, just like this lightning does in the sky in the summertime. And the problem for you is, in the field, if this static electricity builds up in your system, this arcing can cause you a problem. It could ignite a gaseous mixture, or it can shock a worker in the process of neutralizing itself. And so that's why you must deal with it so that doesn't occur. Now, we're going to talk about 4 basics of static electricity in polyethylene pipe. And this is derived from research that the local gas distribution company paid to have done by the Gas Research Institute back in the 90s. And so I'm just going to summarize it for you, but it's something that everybody in the field has to remember. And the first thing, and this is the most important takeaway you're going to take away from this presentation today: static always starts inside the pipe. Why? Because it's the movement of gas, it's friction. It's the static is created by the mechanical shearing action. When your compressors force gas through a poly pipe, as it's forced through, there's just a mechanical shearing action of the gas on the inside of the pipe, and electrons are sheared off and they become orphans, as it were. And so these charges accumulate in certain areas inside the pipe. Now, so the root cause of every static problem you have in your systems goes back to here. This is the root cause. It's the friction of the gas inside the pipe that builds the initial charge of static. This is the most important takeaway I'm going to give you today, most important thing for you to remember, because it's the root cause of all static issues you encounter. Now, this is a little demonstration for our aerosol static suppressor that we recorded. And the purpose of including it in this video is for this reason. Static electricity, you cannot hear it, see it, smell it, taste it, feel it. You do not have the sensory capacity to determine its presence. This is an electrostatic voltmeter, and it's mounted on a board. And on the bottom of that meter, you can't see it, but there's a metal plate. And what happens is this: when electrons start to accumulate, they start to throw off an electromagnetic field. And that field is detected by that metal plate, and the needle will deflect, indicating the presence of an electrostatic field. So the purpose of this video is to show how easy it is to develop a static charge in a piece of poly pipe.
This 60-second video will demonstrate the effectiveness of our aerosol static suppressor in eliminating static on the exterior of polyethylene pipe. We've mounted an electrostatic voltmeter above a section of pipe, and now as we reach over and rub the surface with some nylon cloth and move it, you'll notice the meter is indicating the presence of static. We then take our aerosol, spray the surface, and you see that the surface static has been diminished immediately, indicating no static is present. If it's blue, there's no static.
Now, the reason this is significant is because what we did on the outside of that pipe for 10 seconds is what's going on the inside of your pipe 24 hours a day. Number two of the basics of static and poly pipe. Once that charge is created and generated, it just won't go away. Remember, it's called static electricity because it's electricity that can't move. It's generated on a surface somewhere, and that charge just sits there. It can't conduct away. You can't ground the end of that poly pipe and expect that charge to conduct and move across the surface to that grounding strap because the material won't allow it to do that. That's why we call it static electricity. So you have to deliberately go and dissipate the static where it is. The third thing, and this is not intuitively obvious, I could explain the physics to it. The research has proved it to be true, but just take my word for it because it's too complicated really and not necessary to understand the physics of it. Just, it is true that when that static charge is created on the inside of the pipe, it induces a charge on the outside of the pipe. So basically, when static is generated in a poly pipe, it's generated on two surfaces. It's generated initially in the interior, but it creates a charge on the outside surface of the pipe. Now, that is the reason why in the past, you've done static dissipation with wet rag procedures on the outside of the pipe. And finally, all static charges will arc. Electrical static charges want to go to electrical neutrality. If you give them the opportunity, if you put a worker there, if you expose that charge in a gaseous mixture and there's an exposure to ground, it's going to arc to neutralize itself. And when that arc reaches 3,000 volts, it generates 1,100 degrees heat. That ignites a gaseous mixture. So the static that's generated inside your pipe really creates four problems. Now, we're basically only going to talk about the first one and very, very quickly about the second, and absolutely just gloss over electrostatic pinhole leaks and electrostatic burnout. But static and poly pipe causes these four things, and the root cause of all these things, of electrostatic burnout, and pinhole leaks, shock to workers, and ignition, all goes back to that first slide I showed you, this most important takeaway. All static is generated on the inside of the pipe by the passage of gas. That's the root cause of all these four problems. So we'll talk about primarily today the problem of ignitions and leaking gas during repair operations. GRI says this: every ignition has to have an ignition source. Every one. You can't have an ignition without ignition source. And given what they determined about static electricity being generated on the passage of gas inside a pipe, if you've got an ignition of leaked or leaking gas and you have no obvious ignition source, by default, the probable cause is static inside that pipe because it must have an ignition source. So you really have a very unique problem in distributing gas in polyethylene pipe. In the delivery of your gas, you're creating its own ignition source inside that pipe. That's what's happening. Now, it's important to understand, remember I told you that static electricity is generated on the inside of the pipe. It creates a charge on the outside of the pipe. Whenever we're going to be talking about external static dissipation, and it is important for me to tell you this, and GRI emphasizes it, and that's the reason I include it here. Dissipating the charge on the outside of the pipe does nothing to get rid of the charge on the inside of the pipe, okay? So if you happen to cut into that inside of that pipe and there's static there, you could still have an ignition, even though you've dissipated the static on the outside. Now, we're going to talk about the four most dangerous static ignition operations and how to use our aerosol to mitigate the risk of an ignition. And so these aren't going to be any kind of, deja vu experience for you. You're going to be aware of all these. That's not the point. I want you to understand where the problem is in each of these operations so that if you're using our anti-stat, you're addressing where the static is in that operation to minimize the risk of an ignition and somebody getting hurt. Okay? Now, when I talk about our recommendations, two things I want to make very clear. These are our suggestions. They are not specific procedures required for the use of IGT aerosol. Don't let a PUC person come back to you and say, hey, you're supposed to spray all over the area of this pipe and you didn't, so we're going to fine you. The manufacturer says you're supposed to spray it all over the pipe. No, we do not tell you how to use it. We recommend how to use it, but there's nothing in this that would require you to do this in a certain way and therefore be liable to PUC enforcement. The second thing is always follow your company static suppression procedures. Now, and I'm going to say this also just from a standpoint not of simply because we don't want to tell you how to use the product. But I hope after you listen to this, you'll realize that and after you saw that video, those guys in that actual hole in ONG when they were repairing a third-party damage, if you don't follow your company's static suppression procedures, you run the risk of an ignition. So you do it for your own safety, if nothing else, okay? Always follow your company's static suppression procedures. I don't have time, but I can tell you horror stories where guys who didn't do that. Okay, we're going to talk about the first thing. The most common thing and the most major thing is when you have third-party damage repairs or O&M operations. Now, in this illustration, it's showing third-party damage, and you note there's a jagged edge where somebody's dug into your pipe. Now, where your static issue is when you have a blowing line like this, and as the static and the gas is coming out of the pipe, what happens is the jagged edges on that broken section of pipe create turbulence, and the static builds up on the inside edges of the pipe. And so it's very difficult to get to. If you have a cut line, for instance, the static is going to be, these red patches indicate random static patterns. And so you may cut into a piece of pipe and you may cut into a hot spot. And so you got to understand that you got to get rid of the static on the outside, but you also want to be sure to try to get as much as anti-stat inside the cut or the tear, the damage in the pipe to reach those areas where static is being generated. So when you have a third-party damage pipe or an O&M like this, you want to spray the outside of the pipe from a safe distance of at least 6 inches. Now, we have a reach tool, and I'll show you what that's like. But essentially what it does, it's like an extension pole that holds our aerosol and allows you to stand at a safe distance and spray our aerosol. So when you have a damaged pipe like that, you want to stand outside, spray it from a safe distance, and make sure everything's blue. Then, remember, our aerosol will only dissipate the static charges when the surface is blue. It's wet from our spray. If it doesn't get sprayed, there's still a static charge present. Now, once you have stopped the flow, then you can carefully spray into the cut or spray into the damaged area to try to get the aerosol to touch any of the static that's inside the pipe. Now, if the pipe is blowing, you're obviously not going to be able to get the spray into where it's blowing. Get it as close as you can. And as soon as the flow is stopped, spray on that spot. If you've squeezed off the pipe and you're going to cut into it, spray the tool and spray on that area so our aerosol is carried in with the tool and it can dissipate any static that might be present inside the pipe. Now, again, if the pipe has not been squeezed off, you spray as close as you can to the blowing hole to get as much anti-stat close to that surface of that hole as you can. Now, the second dangerous operation is purging gas. This is kind of really like third-party damage, except it's controlled by you. Now, in this illustration, I'm assuming you have a metal grounded purge pipe. You may or may not. But I want to point out several fallacies, several problems with that. First of all, just because it's grounded does not mean you have a circuit that's conducting the static charge from the pipe to the ground. You're assuming that. There's no way for you to test that. What happens in metal pipe is if there's dirt, there's grease, there's corrosion, there's coatings, all of them act as electrical insulators and static charges can accumulate on those surfaces. So always presume static's present, even though you ground it. Now, again, just like you had that damaged pipe, a third-party damage, and that gas is escaping and the static buildup is in the turbulence of the cut. It's the same way on the in the edges of the opening of that purge pipe. Static is going to build up on those inside edges. And if you've got a joint with a coupling that metal pipe with a plastic pipe, because the joint will not be perfectly smooth, you'll have turbulence between the metal pipe and the plastic pipe joint, and static can build up there. So you should be aware there's going to be static inside that connection, inside that pipe. So after your purging is done, use our reach tool and spray inside the pipe to about 12 inches below where the metal pipe and joint is, okay? And spray the inside edge of it. And then also, and begin spraying as you get closer to it. And then also when you take it off, spray inside it too. Okay, now the third major operation is when you're doing repair operations downstream of a squeeze off. What happens with squeeze off is, and we'll be talking about it in the second point of the shock aspect of polypipe, but when you squeeze off a piece of polypipe, the Venturi effect takes effect. And what happens is, as the gas pipe gets narrowed as you're squeezing it off, the velocity of the gas increases trying to get through the narrowing opening. And when the velocity increases, the friction increases. So it's not unusual at all to have huge amounts of static downstream from a squeeze-off operation, as indicated by these red patches on the pipe. It will also develop upstream, not as far, but it will develop upstream from your squeeze-off. So when you're getting ready to cut into that pipe, you want to spray the outside of the pipe. Before squeezing it off, spray the outside of the pipe and then respray it after your squeeze off before touching it, because again, it has such a high voltage being generated. And so when you're cutting into that downstream, again, try to spray onto the tool, spray into the cut to carry our anti-stat inside where that static is going to be generated. Now, when you're doing hot taps, when you put that tap on, you may put it on a spot as indicated here by that red patch where you're fusing it right on top of a hot spot of static in there. You don't know it. There's no way to tell. So what we recommend is when you do that, after you spray the fusing in there, spray the inside of the tap before you bring the tap and spray the tool with our aerosol static suppressor. And then use that as that aerosol goes down in there, it'll kind of dribble in there. And if it comes in contact with any static, it'll dissipate the charge. Don't worry about the IGT aerosol getting in the gas stream. It's, it won't bother it, and you won't get enough in there to make any difference. And be sure just to wipe the tool off of the IGT aerosol when you're done. Okay. And finally, when you're cutting into a piece of pipe that's previously under pressure, been removed for service, or cut into or reached into, always spray the outside of the pipe and the tool with aerosol. I had an instance where a couple of guys, it was out in western United States, and they had a stubbed line, about a 6-inch stub line. And what had happened, they were going to extend the service on the stub line. So they shut the line down, took it off pressure, and these guys went with a tool and went to cut through the pipe. And as soon as it broke through on the inside of the pipe, there was a boom. And the two guys went to the emergency room. No fire, electrical shock. The gas utility was embarrassed because they hadn't called for a locate. They called the local electric company and said, hey, sorry, we cut into 2 of your lines, some of your electric lines out here. Electric company says, we don't have any lines out there. And it was static electricity in that stubbed line. I also had an instance where a polypipe was cut and removed from service for some reason. A guy reached inside it. There was still enough residual static and methane in there. It flashed and burned hairs on his arm. So always spray the surface you're cutting into. Don't never reach into a piece of polypipe without spraying and dissipating the static charge in there. And if you have to reach inside it, then use a tool or a reach tool to get inside there to spray inside that pipe. And if its pipe has been under pressure and everything, and you're going to open it up, spray a 1-inch band around it before cutting into it. And always, whenever you're cutting a piece of pipe, spray into the cuts as you're doing it. So our aerosol is carried into the cut when you're sawing it. That'll dissipate it'll help dissipate any charges it encounters. Now, I want to talk to shock to workers. We're going to go back to squeeze off because this is the primary area where this is the case. Again, the static charge in there is so high. I had a report. There have been burn fatalities in the gas industry and O&M operations. That's no surprise. I hadn't heard of a serious shock incident until about 5 years ago when I was teaching the static class at the Northeast Gas Association Gas Operations School. And I was told of an incident that occurred up there where some guy was working and the static electricity from the pipe arced through him and went through him and out his big toe. And what it is, it's all the static being generated inside that pipe. It could be during normal operations, but especially at squeeze off, you have to be extremely careful. And what happened is it was so bad, it stopped his heart. So they had to paddle. They had to give him the heart paddles and then defibrillators. And then he had his big toe amputated because it burned his big toe where the charge went out. So it's absolutely imperative that you always ground your tools. The grounding of tools is not a static suppression procedure. It is a worker protection procedure. So if you encounter a charge, the charge goes through the tool, through the grounding strap, and into the ground. If you disable your grounding straps or do not use them, if you encounter a static charge, that static charge will come through the tool to you and out the bottom of your feet or out your arm, and you do not want that. Now, I want to talk to you about the two last threats, which are electrostatic pinhole leaks and electrostatic burnout of electronics. Static electricity causes pinhole leaks in polypipe. In some systems, I've had instances where when we got rid of this pinhole leaks, there was an 80% reduction in leaks. There is probably a lot of leaks in your system, which you just think are leaks, when in reality, they're being created by static electricity. That's not my point in this to talk to you about that. The reason you need to be aware of that is this. It is very common when you squeeze off pipe, the static charges are so high downstream that they put pinhole leaks in the pipe. So therefore, when you squeeze off, you should always soap leak test the pipe, all the exposed area before you bury it again to make sure you don't have any electrostatic leaks. If you find pinhole leaks in your system, it is not bad pipe. It is every time pipe manufacturers have been accused of having defective pipe. Forensic lab analysis 100% of the time has said it is static electricity. It is not a defective pipe. If you have that problem, call us. And finally, the other thing you're going to start to see more and more is you're going to see electrostatic burnout of electronics. If you have solid state electronics, which is extremely sensitive to static electricity, and you have static in your system, that static can arc through a barrier, arc to the electronics and burn it out. I've had instances of locator transmitters being burned out when the static charge inside the pipe arced to the tracer wire and back to the transmitter and burned it up. So remember what I said before. There's 4 threats from static electricity: ignitions, shocks, pinhole leaks, and electrostatic burnout. And the root cause is that cause number 1, the slide I told you, don't forget. All static is generated by the passage of gas inside the pipe. It starts internally. That's the root cause. It manifests itself in ignitions. It manifests itself in shocking workers. It manifests itself in creating pinhole leaks. It manifests itself in burning out solid state of electronics. Okay? Now we can talk about our static suppressor. Okay, so our static suppressor is a state-of-the-art static suppressor. Back when in the 80s, when polypipe was started to being used in the United States, this problem of static electricity became evident. The problem was there was no other solution. AGA recommended wet rags. What essentially it is a grounding mechanism. You take those wet soapy rags, you wrap it around completely in the surface, trail it to ground. You assume there's a connection. You don't know. You assume there's electrical circuit that the water and the soapy water has completely covered the pipe, and any static charge is transmitted by the water, conducts through the water down to the ground. It is very clumsy. It's very awkward. It's dirty. It's slow. It's labor intensive, but that's all you had. Our aerosol static suppressor is designed to replace that. It's an all-weather static suppression product, very versatile. You can use it in a lot more operations than you could use wet rags. To make sure our product would not affect PE, would not affect your fusing operations, that it was not flammable, and it was effective as wet burlap and eliminating static, we went to the Gas Technology Institute's testing labs, and they evaluated our product and made sure that it doesn't affect the PE, doesn't affect fusing, it's non-flammable, it's every bit as effective as wet burlap in eliminating static. And if you'd like the report, we can email it to you. Now, the nice thing about our aerosol is when you have soapy burlap, you have to keep that burlap wet, the pipe wet and everything. You don't have to do that with ours. When you spray the surface, that's it, you're done. And you don't have to ground it, you don't have to keep it wet. When you spray a surface with our aerosol, it'll eventually dry down. It is still dissipating static even after it dries. Now, our aerosol comes in two formulations. We have customers that are in very cold climates. So we have a regular formulation that sprays to freezing, actually maybe a little bit below freezing. And then we also have a formulation, if you are in climates where you have to do repair work under 32 degrees, we have a low temperature formulation. It'll spray to -20. In both of these products, they work identically, except one has a lower freeze point. If our aerosol would happen to freeze on you, don't worry about it. Thaw it, shake it up, it's fine. Now, again, it's very simple to use. You just point and spray. Get about 6 inches away from your target surface. It's going to mist a 4x6 area and just dampen it. You don't have to, get it wringing wet. Once it's damp, the static is dissipated, and overwetting will not increase any static dissipation. If the area is blue, you can see it blue, there's no static. Our can will spray upside down or right side up or sideways. Now that's important when you have our reach tool. So let's say you've done a squeeze off, you have an excavation, you've done the squeeze off, and now you want to dissipate the static. Our can on the reach tool holder, you can tilt the end and you can spray upside down if you need to. This is just a little demonstration of just how to spray it. Whoa, no, it didn't work well. Here we go, let's try this again. So just a simple spray, doesn't have to get super wet. That's all you need to do. Now here's our reach tool, and it's designed so that you can spray a dangerous situation from a safe distance. The pole that we supply to you is a non-electrically conductive pole. That means it cannot conduct the charge as long as it stays dry. I mean, if you have it wet or something, then you defeated the purpose. But all you do is insert our aerosol can in the holder and tighten it up. And there's a limit market there. You just tighten it up and then you're ready to go. It will sit there. Whoops, it will sit there. And this is just a little quick demo to show you how you put it in the can, just tighten it up, and then it allows you to spray any kind of surface from a safe distance. Again, if our aerosol freezes in the can, don't worry about it. Just thaw it out. It'll be fine. Shake it up. Now, when you spray it on a surface and it freezes, don't worry. Remember, the liquid, there's water and a few other chemicals in there, but the anti-stat, when it's on the surface, even though it would freeze, it's still effective in dissipating the static. Reapplication is not necessary. While we have two different lower limits on the aerosol, there's no practical maximum temperature because the temperature, if got high enough that it makes our unit effective, you're not working in that. So you don't have to worry about that. Don't apply our IGT aerosol when it's raining or sleeting because it's just going to get washed off. So wait till the rain stops or the sleet stops and then spray it on the surface. Make sure, visually inspect it, make sure that all the surfaces are blue from the static spray. Only surfaces that have been sprayed with our aerosol are going to have static dissipated, okay? Now, let's say you spray a piece of pipe and you have, for some reason you have to leave. You don't necessarily have to respray it when you get back to ensure the static is dissipated. Now, if you're gone for a couple of weeks or it gets rained on, yes, you've got to respray it. But generally, if you leave it for a day or two, you shouldn't have any problem. Always spray the pipe surface first. Why? That's where the static originates. That's the root cause. And then after you do that, if you want to spray another surface, a tool, anything like that, go ahead, but always spray the pipe surface first. Our aerosol will dissipate static immediately on contact when it dampens it. And that surface could be anything. It could be plastic, it could be metal pipe, it could be a tool, it could be clothing. Don't recommend it on clothing, but people think that static electricity cannot build up on pipe. That is not true, not true. Any kind of pipe that has a coating on it, or any kind of pipe that has oil or grease or dirt, those areas act as electrical insulators, and static charges can accumulate on those areas. So you can use our aerosol on those surfaces. Remember, our aerosol will not get rid of any static on surfaces it doesn't dampen, and static inside the pipe is not dissipated when you spray our aerosol on the outside of the pipe. You can spray IGT on any tool to eliminate any static present, and it does not affect your grounding. It will not affect the grounding of tools if your company procedure is to ground tools. I had a call recently from a guy who their procedures, they're writing our anti-stat into their procedures, and they said you could set the tool on top of when they sprayed the pipe, and he thought our aerosol would act like as a barrier from the pipe to the grounding tool. It will not. Actually, it'll be an electrical conductor. It will make your grounding tool work better. So you don't have to worry about having sprayed a pipe and putting the grounding tool on it and there being our aerosol static suppressor on the surface of the pipe when you ground it. Do not change your company procedures concerning grounding tools when you use IGT aerosol. You don't have to remove our aerosol from the pipe when you're done. It will biodegrade. You can simply bury it and abandon it, and it doesn't affect the pipe, and it just naturally degrades over time when it's buried. If you're fusing, you're going to prep the surface according to the fusing company procedures. That will remove any residual IGT aerosol spray. Now, this will either be wiping it off with a clean rag, washing with soapy water, scraping, or wiping with an ISO rag. So if you're fusing, just be sure you prep the pipe according to the fusing fixture manufacturer's instructions. If you're using mechanical couplings, just clean the pipe ends and remove any residual IGT, just like you were doing fusing operations, and it will be just fine. We recommend, people have asked us, what is the expiration date of our aerosol? Well, really, if it sprays, it works. But some companies said, hey, in our procedures, we have to have a drop dead date. So we recommend use within 2 years of the manufacturing date. Our packaging date and formulation is inkjetted on the bottom of the can. Here's the legend on how to do it. If you have any questions, you can always email us, but we can identify what the product is and what it was packaged if you just give us the inkjet on the bottom of the can. We recommend 2 years. Again, use it within 2 years. Your job is not to inventory it. That's our job, and other people like MRC and people like that. So you shouldn't have to have a lot of inventory that would wind up being expired inventory. Disposal of the aerosol cans. You can dispose of them according to local ordinances and your company aerosol can procedures. Now, most aerosols in the United States use propane as the gas to push out product. When you have paint like Rust-Oleum, remember when you were in college, you'd get the aerosol can of deodorant, you put a match and it'd burn. Well, that's because they use propane in there to push out the product. We do not use propane in a hazardous environment. Our aerosol actually contains nitrogen as the propellant. And in doing so, actually, it's really almost like a fire extinguisher. It'll push out any oxygen and, in a sense, suffocate a flame. But our aerosol doesn't contain any hazardous materials or gases, It's aluminum, so you can recycle them with aluminum cans. Follow your company's procedures for using an aerosol product and disposing of it. Again, personal use considerations. It contains no hazardous materials. If you, like with any aerosol, avoid inhaling the spray and contact with the eyes. Our SDS is generally kept by your company. Also, there's independent SDS purveyors that have it and that hold our aerosol. So basically, if you get it on your hands, just wash it off. Or if you get it in your eyes or something like that, just wash it off with water. Just rinse it off and wash your hands with soap and water. Repeated contact, you may get a little itch, what they call contact dermatitis, but that's all it is. If you wash it well on your hand, wash your hands, it'll go away. So that is the end of this. Feel free to share this link with anybody. If you have any questions about our aerosol static suppressor or reach tool, if you have any questions about us doing this as a safety video, a Zoom meeting for your company, just let us know. We appreciate you taking the time to watch this. I hope it was helpful. As always, you feel free to call us when you have any static questions at all. So with that, we are going to finish this meeting.